Let's talk about ghosts. Not those ghosts. Not really. In physics, the ghost noted here isn't quite the same as the ghost here, but maybe in a way they are. My name is Lauren Hellickson, or Lauren Haunts, and I am your friendly neighborhood spicy-brained witch who loves all things super nerdy, especially physics, and I have a knack for comprehension. I love teaching, and I want to help you understand some of the overly simplified theories and concepts in physics that I think run amok in the paranormal. The term ghost will sometimes show up in quantum or particle physics, and it often relates to a concept called ghost particles. Now, some of these ghost particles are actually something called a neutrino, and they're incredibly difficult to detect. Much like the entities that you see, feel, sense, or that maybe make your proximity sensor go off. The difference, though, is that there is no piece of ghost hunting equipment that could even start to detect these ghosts. Neutrinos are produced during nuclear reactions, like the sun or radioactive decay. They barely have any mass and rarely interact with matter, which means they can pass through you, me, entire planets without being noticed. When we use paranormal equipment, basically anything that's on the market that says it can alert us to changes in the fields of energy around us, we're only able to depend on protons, electrons, photons of matter to deliver that information to us. The base word of neutrino, sound familiar? Neutrons. They hold no electrical charge, nor are they attracted to or repelled by any other particles. They're like the Switzerland of matter. Nerd joke. So imagine a huge room filled with a few hundred people. Look up towards the ceiling and you notice a square window that's only about an inch by inch with a nice cool breeze coming through it. You would have more luck detecting that breeze from across the room than ever detecting a neutrino, even with advanced equipment. Now, there is another concept that may sound more akin to the spirits that ghost hunters are wandering through graveyards looking for, and those are gauge ghosts, or virtual particles. These are noted most in a branch of physics called quantum field theory, and if that does sound familiar, it's the same branch of physics that is known for that mystically described double slit experiment, which was actually an experiment done in 1801, and it did reveal the wave-particle duality of wavelengths in electromagnetic radiation. My favorite. In this case, of the time, it was the wave-particle duality of light, which is truly a magical seeming discovery in science. Okay, back to gauge ghosts. Sometimes they're described to pop in and out of existence very quickly in empty spaces. And though they can't directly be observed, they can have effects that scientists can measure. However, these aren't actually particles in the way that we might understand them or think them to be. They're essentially theoretical ideas of particles, or concepts of particles, if you will. Almost like open spaces in the calculations that we don't quite have the understanding to fill yet. And this is where I think the parallels start to form. Gauge ghosts ensure the mathematical structure of gauge theories remain consistent. In some cases, if gauge ghost fields were not included in the calculations, you would get incorrect, infinite, or completely nonsensical results. They play a crucial role in ensuring the overall coherence of a theory. They're like a placeholder, an invisible weight that grounds the science while more research is done. So it's important to recognize that gauge ghosts are not physical entities. They don't correspond to anything real or observable. Kind of how I truly believe the idea of ghosts and the paranormal are just a placeholder that we've put in to make phenomena feel more approachable or understandable and maybe even just a little bit more digestible, but they don't actually exist. Maybe because it's like much bigger than that. Kind of like in theoretical physics, it's really common to make certain assumptions or introduce constructs to simplify complex problems and make the math work out in a way that reflects physical reality. Because a lot of these experiments are done in a vacuum and they don't really relate into our world, into this world that we can observe or that we will ever come in contact with. Gauge ghosts are just one example of this practice, helping to maintain the integrity of the theory while revealing useful predictions. So when you hear the term ghost in physics, think of them as an important role in our understanding of the universe. These ghost particles remind us that there is and always will be so much more happening around us than we will ever see. Happy hunting.